Hello and welcome to a follow-up of my shader package project. You might have seen this one here, a widget that takes your GLSL shader code and compiles it via my web service. You can hot reload, work on your shaders and try them out and use it within your Flutter application. I'm working on a follow-up on this and provide a way to add shaders with much comfort to your production app. I'm just copy pasting the glowing ring example and pasting it into an empty Flutter app. Hot restart it, and here we have this glowing ring. And what happens is this shader code is being compiled on runtime against my web service, and we want to avoid this. We want the shader code to be part of this project, like this. Adding a directory with shader and say we have a fancy ring shader GLSL file and put it right in here. So how do I compile the shader file? For this purpose I added the shader command line executable. Just type shader and press enter and you see everything that this small tool can do right now. And for a simple compiling, I just say shader, use the web service, and it uses my remote compiler and it compiles those into the SPR-V file that I can load at runtime. I also can say, hey, this SPR-V file, I wanted to access it via the assets root bundle. Just use the A flag and it compiles those into the assets directory. Yeah, this is one thing. And but now you're asking, okay, I'm again dependent on your remote compiler. No, with the shader CLI you can also address a local instance of your shader C package. For example, here you can see download it, shader C, go to the download section and pick your operating system. And I have it in my STK directory, like here, and I just need to point it to those directory and it scans those directory for the GLSL binary like this, and it's using it to compile it. And with this way you're independent from my web service. Okay, what we can do next is another output format. It's the Dart output format. When I just saying Dart, instead of having this SPR-V file, we have a generated Dart file containing all the SPR-V bytes, but also allowing to have a function that loads this SPR-V into a fragment program via a future. So I can use a future builder just to load it and have everything embedded. I don't need to hassle around with file loading or asset loading. I can use it like this. Yeah, let's try it out inside this app. We don't need this shader code anymore. We just need a future builder. And this is my fancy ring shader fragment program. And I'm done. Just need to fix the API here, snapshot. And the future is the future of the type fragment program. And here snapshot data. If it's null, show some loading indicator. If my snapshot data is available, I can pass it to the shader painter and do something with it. And hot restart. And here we have this fancy ring animation independent from my web service. It's just baked into a Dart file. Isn't that amazing? But there's one more thing. You can add a watch flag like this. And now it's watching for changes to GLSL files and updates them as needed. For example, if I'm removing the shader and let's say make every color of each pixel to red. Now save, hot reload, et voila, I can write my shader with hot reload in mind. Isn't that amazing? Yeah. I hope you guys like it. I will update it along with this package shader soon. You can try it out already. Just go to the shader CLI package. They have some quick documentation and use the help flag and try things out like this in the video. Yeah, I'm very happy to see some cool shader effects within your Flutter applications.